Hello, welcome back to our channel. Today we are going to discuss about electromagnetic waves. It is very small chapter and limited formulas are there. So don't leave this chapter also for both MSET, NEET as usual for main students also. It's very easy to learn these formulas and you should practice the problems also. Look here, now we are going to come to our topic. What is the electromagnetic waves? You know that when charge is at rest condition can able to produce only electric field, but when the charge is in moving condition it can able to produce both electric and magnetic fields. It was discovered by the Maxwell, and we can say that light rays are the electromagnetic waves. Previous many people they said particle wave, and you know that is having the dual nature matter. So like that here what happens, that light waves are nothing but electromagnetic waves. So accelerating particle also can able to produce both electric and magnetic fields perpendicular to each other, and it is having the straight line path also. But the thing is, you know that in previous two chapters, moving charges and magnetism, moving charge can able to produce the electric field, magnetic field around it. So like that, magnetic change in magnetic flux is producing the induced current, that is in electromagnetic induction. And you know that Ampere circuited law. What is Ampere circuited law? Line integral of B bar dot dl equals to mu naught times of the current, that is the Ampere circuited law. But Maxwell observed some uncertainty in this, some uncertainty in that, and he modified that formula. And here we have to consider both current due to the conductors as usual in the case of that displacement current. So here you know that flow of electrons is giving the conduction current, but one more also he given that is the displacement current. That is because of the rate of change of magnetic flux, and rate of it is directly proportional to the rate of change of magnetic induction also we are taking. So here the new term is the displacement current or displaced current also we can say that. So already Ampere circuited law, what we are saying, line integral of B bar dot dl is giving mu naught times of the current. But here the magnetic lines of force and that one coming, leaving and coming both are same. But here in the case of capacitors, condensers, we are observing the displacement current. Anyway, come to this point, conduction current is directly proportional to rate of change of magnetic induction. Then displacement current is directly proportional to rate of change of intensity of electric field. So this is the new term here. Then you know that already in previous chapter, electric flux equals to line integral of E bar dot ds bar. E bar belongs to intensity of electric field, ds bar is nothing but area of that one. Then what is the displacement current? How to write the expression for that? Look here, displacement current equals to epsilon naught times of d by dt of electric flux. Rate of change of electric flux into this permittivity of free space is called the displacement current. When we are doing the simplification, when theta is 0, instead of d bar dot ds bar we are writing eds. Instead of ds I have taken area of that particular surface divided by dt. Here a is constant, a into epsilon naught. Instead of e equals to v by d. Potential by distance is nothing but intensity. Then we are taking this distance also does not changing with respect to time. So a into epsilon naught by d is called the capacitance into dv by dt. See, this is the formula for displacement current in terms of electric flux and epsilon naught. And this is in terms of intensity and area. This is in terms of area, potential and distance. And this is in terms of capacitance and rate of change of potential is giving the displacement current. Now you see how he modified that, recorrected that Ampere circuited law. Line integral of B bar dot dl bar is equals to mu naught times of that conduction current plus displacement current. Suppose this is the 4 amperes. This displacement current is the 10 amperes. 4 plus 10 is the 14 amperes into mu naught value. You know that 4 pi into 10 to the power of minus 7. Then this is the Lorentz force, and one of the, he is also, this is the scientist name. And how this, you just now we said, I said that accelerating particle can able to produce both electric and magnetic force. How we can see graphically, we can draw like this. Along the z axis x-axis and y-axis. See, E bar equals to Ex I cap E naught into, this is intensity is along the x-axis, E naught into sine kz minus omega t. Then B bar equals to along the y-axis, By into j cap. B naught and E naught are the maximum intensity due to electric field, and this is the induction due to the magnetic field, sine kz minus omega t. So whenever we should treat these are like wave motion, means we have to express like harmonically either in terms of sine function or cos function. So here we have taken x-axis, y-axis and z-axis. This is the resultant of these two, velocity of the light. So in this case what happens, intensity is along the x-axis due to the electric field, magnetic induction is along the y-axis. That's why in terms of this is along the x-axis, what is the unit vector? Unit vector is the I cap. So Ex I cap, instead of Ex, E naught sine kz minus omega t. Kz is what? K is the propagation constant and omega is the angular frequency, and with respect to z-axis we are taking. Then B is along the y-axis, you know that j cap is the unit vector. So B naught is the maximum induction of that magnetic field into sine kz minus omega t. So now you know the intensity of electric field and intensity of the magnetic field, because of what? Accelerating charge can able to produce the both electric and magnetic fields. Now see what is the importance of this one. Always we are saying that velocity of light value is 3 into 10 to the power of 8 meters per second. They discovered already from that. From where they got that value, look here. That is coming from ratio of intensity of electric field by magnetic field, and E naught by, even you are doing maximum of this one by this one, equals to 1 by under root mu naught into epsilon naught. So in this you can take anything, we are getting that value is the 3 into 10 to the power of 8 meters per second. Then suppose light, you know that in vacuum or free space 3 into 10 to the power of 8 meters per second. But in medium, how to find out? 1 by under root permeability of the medium into permittivity of that medium. It should be right 1 by under root, instead of mu naught into mu r, instead of epsilon naught into epsilon r also you are taking. So in terms of relative permeability or free space permittivity also we can find out the velocity of light in medium. Don't confuse here. Then we are focusing on the energy density. Energy per unit volume is called the energy density. But here energy density is formed by, in the case of two things, due to the electric field and due to the magnetic field, and total energy density is the, see, UE plus UV. UE is the energy density due to the electric field, 1 by 2 into epsilon naught E square. Like that, magnetic induction is the B square by 2 mu naught. When we are adding these two, it is giving the total energy density of that electromagnetic wave. So you must remember these formulas also. Then intensity. Intensity, you know that power by area is called the intensity. It is coming in waves chapter also. Area of that spherical shape we are taking 4 pi r square. But in terms of energy density, you are writing energy density by area into time is giving the intensity. In terms of average density, U average into velocity of light also giving the power. Then next one is the electromagnetic spectrum. You are having this concept in chemistry also. So based on that wavelength and frequency, we are taking the electromagnetic wave spectrum. Here first thing is the gamma rays. Gamma rays wavelength is 10 to the power of minus 14 meters to 10 to the power of minus 10 meters. So this is the wavelength range of the gamma rays. These are having the high penetration and low ionization. Then these are affecting the photographic plate. But where we are using this gamma rays, in medical we are using that gamma rays to kill the cancer cells. We are using the gamma rays. The next one is the X-rays. This wavelength range is 10 to the power of minus 13 meters to 10 to the power of minus 8 meters. You know that practically X-rays are useful. Any bone fracture is there, we can find out with the help of the X-rays. Not only this one, for finding the crystal structure also we can able to use the X-rays only. So in medical field and for finding the crystal structure also we are using the X-rays. Then next one is the ultraviolet rays. This range is 10 to the power of minus 7 meters to 10 to the power of minus 10 meters. So ultraviolet rays, you know that water purifiers, and that one for purifying the water we are using the ultraviolet rays, and in medical field for killing the bacteria also we are using the ultraviolet rays. Then you know that visible region, because of this only we can able to see the things, we can able to see the objects, and we can able to see here something is there like that. So it is possible in the case of visible region. The next thing is the infrared rays. For physiotherapy and some therapy in medical field they are using the infrared rays. Not only this one, in fog, in fog also we can able to take the photographs with the help of the infrared rays. Not only this one, for some special effects in cinematography also we are using the infrared rays. The next one is some microwaves. You know that microwaves we can use for like domestic purpose. In that microwave ovens, with the help of that rays we can able to heat the food and all these things. So not only this one, in radar system also we are using that one. So these are the electromagnetic spectrum of that electromagnetic waves. So this is very small chapter, electromagnetic waves. Easily you can learn that. The new thing in this is the displacement current. So the rate of change of electric flux into epsilon naught is called the displacement current. Because of this reason only he modified that some uncertainty is there, Ampere circuited law. So now you should write it mu naught equals to sum of the conduction current plus displacement current. Suppose we are doing few problems based on this. See, look here, we have to find out the energy density due to the electric field. See, if you remember that epsilon naught value is 8.85 into 10 to the power of minus 12. Intensity is the 2 Newton per coulomb. Then how to find out the intensity, energy density in the case due to the electric field? Half into epsilon naught into E square. So half into 8.85 into 10 to the power of minus 12 into this E square is the 4. After simplification, our answer is what? Energy density equals to 17.7 into 10 to the power of minus 12. So what is the unit for this? Joules per meter cube we can take it. Like that we can able to do the problems. Then not only this one, suppose electric field, force due to the electric field is the 10 newtons, due to the magnetic force it is the 20. Total force on that electromagnetic waves, just you can add 10 plus 4 is the 14 newtons we can take it. Like the total energy, suppose we know that B equals to 4 pi Tesla. Then how to find out the energy density due to the magnetic field? V square by 2 mu naught. V square by 2 mu naught. So instead of V square, what we are writing here? Here UB equals to V square is how much? I have given 4 pi Tesla. Tesla is the unit of this magnetic induction. So 4 pi into 4 pi by 2 into mu naught value is 4 pi into 10 to the power of minus 7. This 4 pi cancel. Then UB equals to how much you are getting? This is 2. Answer is 2 pi into 10 to the power of minus 7. So like that, with the help of the formulas you can do any type of the problem like that. This is about the electromagnetic waves. It is very small chapter. So if you want other chapters also, almost 97% I have done that. Only few chapters pending, that also I am completing before the exams only. Whatever I have completed, better you should go through the formulas and you have to do the work out the problems, few problems at least chapter wise. Then I think it is very helpful for you. Thank you everyone. Please subscribe my channel and share my channel to your friends also.